A lot of people, when they think of radiation, they think, I only get exposed to that dangerous, nasty stuff if I go to the doctor and get an x-ray, or if I go to a nuclear power plant, or if I am in the military working with nuclear bombs or something like that. I go to Hiroshima, there'll be some leftover radiation, or something like that. And the truth is that is absolutely incorrect. Right now, you, sitting in your chair at your house, I would assume, there are, give or take, a million or so nuclear decay processes, a million or so atoms decaying I believe, per minute in your body. Radiation, nuclear decay, is happening all around us, all the time. You are constantly, no matter where you are, no matter what precautions you might take, you are constantly exposed to radioactive materials and radiation itself. This is what we call background radiation. There is some low-level amount of radiation that is always present. It does vary a little bit from one place to another, and we'll talk a little bit about that in just a minute. And it will vary a little bit based on your, your lifestyle, where you work, things like that, what you eat. It'll vary somewhat. But everyone, no matter what, is exposed to some small amount of radioactive material. This can be in the air, in the ground, in the water, in the food that you eat, coming up from the soil. It is all around us. And this is not necessarily a bad thing, actually. There have been some studies that have actually shown that areas in certain countries where there is more background radiation up to a certain point actually have less cancer, less diseases that are associated with being exposed to high energy radiation. Obviously, it's kind of difficult to do studies on those types of things because that would require you to intentionally irradiate people, and the ethics boards of different colleges and institutions tend to frown on intentionally irradiating people for the sake of a study. But there has been no evidence that living in one area with a higher background radiation versus another area gives a greatly increased or even slightly increased amounts of cancers and things like that. Not that I've seen anyway. Feel free to correct me on that if you know of some data that contradicts that. The average person, and I believe this is for Americans, but it might actually be worldwide. I'm not 100% sure. But the average person, for sure in the U.S., most of their radioactive exposure, most of their radiation exposure, comes from radon, which is a radioactive noble gas. It's way down there at the bottom of the noble gases. And radon is produced from things like uranium and thorium, breaking down, decaying in minerals that exist down in the soil, down in the rocks and everything down beneath us. And as that uranium and thorium decays, it eventually will turn into one isotope of radon or another, just depending on how the decay process occurs. And that radon is a gas. So it was a mineral before that. It stayed in the solid phase before that, but when it turns into radon, it actually does become a gas, and it will seep up through the ground, and it can get into your house. It can leak into anywhere that air can go. It is especially dangerous if you have a relatively high concentration of radon in your house, though, because that air is stagnant. And so if you do have a relatively high amount of radon that's getting into your house and it's just sitting there in the air and it's getting into your lungs, that could potentially cause problems. Other sources of exposure are just minerals in the rocks and soil. There's quite a lot of thorium, for example. Thorium has very, very low, or I guess I should say very, very long half-life, but there's a relatively large amount of it. And so even though it's not terribly radioactive, there's enough of it around that it can add to your annual exposure. Cosmic rays, those are radiation coming from space. So that would be mostly gamma rays, probably. Gamma rays, X-rays, and even UV coming from space that gets through the atmosphere and gets to you. And then there's just radioisotopes that exist naturally in your body. I believe your body is about, it's either 1% or 0.1%. I'm pretty sure it's 0.1%. I think your body is 0.1% potassium. And potassium is about 0.1% made of potassium 40. Potassium 40 is a naturally occurring radioisotope of potassium. It is actually recharged, if you want to call it that, by radiation coming in from the sun, very similar to how carbon-14 is recharged, so to speak. There's a constant amount of carbon-14 as long as you're taking in new carbon. That amount of carbon-14 has a homeostasis. It's the same thing with potassium. Potassium 40. As you take in new potassium from doing things like eating bananas, you get more potassium 40 as you take in all the rest of the potassium. And so you actually just have a naturally occurring amount of radioactive material just in your body, and it's mostly that carbon-14 and potassium-40 are the most common, by far the most prevalent radioisotopes that exist in your body just naturally. And simply because of the unimaginably huge number of potassium atoms and carbon atoms you have in your body, that's where we get that, million or so radioactive decays per minute in your body. Just because you have so many of those, even with a million or so a minute, there's trillions upon trillions upon trillions of those atoms in your body, and so it's perfectly fine to have those, and your body's built to handle that. You can handle having those radioactive decays occur, even if they damage some of your cells. Your body can take those damaged cells and either fix them or scrap them and make some new ones. So those are all naturally occurring sources of radioactive exposure. But if you do go into the doctor's office to get an X-ray, either at the dentist or you break a bone or something, you get X-rays, or if you have some kind of a more grave illness and you need something like a PET scan, that can make those could easily, especially if you have a PET scan or something like that, or a CT scan, that will easily blow away your exposure to radon for the year. A single CT scan is more than all of your radon exposure for a year. Which is why doctors don't like to just willy-nilly do scans like that. If someone doesn't come in and say, I have a little bit of an itchy throat, I'm like, okay, give them a PET scan. Nothing like that. On top of that, PET scans are expensive, but they don't want to expose you to more radiation than you would need. Now, a little thing like a dentist X-ray, that is a very, very minimal amount of exposure, and it's very localized, and so there's not really any need to worry about that. That is much less than your annual exposure to radon. But there are certain kinds of scans, especially if you're having like some kind of a heart surgery done, they'll be essentially just continuously scanning as they do those. And so you'll get a lot. But the risk of getting exposed to quite a bit of radiation or having a heart that doesn't work, I would take the radiation. So there's also a good bit of radioactive material in consumer products. So like any kind of makeup material where the source for the minerals that goes into those, those comes up from the ground. There'll be trace elements that are radioactive in those, which is not to say that you shouldn't wear makeup. It's perfectly safe as long as the makeup itself is not interacting with you. I would not worry about the radiation portion. But there are other things as well. So like if you have a marble or granite would be more likely, kitchen tabletop or something like that, there is a disproportionately high amount of uranium and thorium in granite and marble as well. And so those are going to be slightly more radioactive than other tabletops if you just had a wooden tabletop. And so just, other consumer products like that, you get a little bit of exposure from. Most of it is natural for the average person, though. Speaking of radon, this is a map of the different zones in the U.S. where there's more or less radon. Since radon is by far the largest exposure that the average person has, they do try to map these things out. Most of this is determined by geology. It's determined by what's in the ground. And you can really tell that in certain areas, like you can see how this zone here of red, which is the higher amounts of radon, it very closely follows the Appalachian Mountains. So the Appalachian Mountains are kind of all through here. I'm not sure how far up north they go, but I know they go down through here into Virginia, this side of North Carolina, Tennessee. I've driven through there many times. I used to live in Raleigh, North Carolina over here. Family was over here, and so we would drive back and forth here. And so there's a high amount of, and by high I mean relative to other places, a high amount of radon in those mountains, which honestly, some of them are more like hills. They're very, very big hills. But that's because of the geology there. The rocks that are in the ground have more uranium and more thorium and other radioactive elements than the Ozarks do. Same thing here in Colorado. There's just more granite in the ground, and so it's just naturally more radioactive in those areas. All right. So here is just, again, a little bit more information on the amount of exposure that you get from certain things. These are more medically focused here. So here's the annual public dose limit is what this says here, which I believe, let's see, what is this measured in? Millirems. So that says 100 millirems. I think this is the amount that you're allowed to get exposed to. Well, I don't want to. I can't remember what this actually means. The annual public dose limit. But feel free to look that up because I'm blanking on exactly what that comes from. Because I know it's not the amount that you're allowed to have, and if you get that amount, then you're not allowed to get any more. Because here we have the average U.S. annual dose right here, which is a lot higher, than the that public dose limit. So, but just again to give you an idea, this is the amount of exposure that the average U.S. person gets exposed to in a year. And a single whole body CT scan gives you 160% of that, or not, it gives you 100% of the amount that you would otherwise, and then an extra, well, not 60%, an extra, well, yeah, it is about an extra 60% on top of it. So CT scans, not something you want to do just for funsies. But other things like chest x-rays or taking a flight across the Atlantic, believe it or not, there's quite a bit of radiation up high there in the atmosphere. But it's even less than you get exposed to just from, the stuff that exists in your body naturally. So it's something that you are constantly exposed to, but you don't really need to be worried about too much unless you get up to this value here. So this is the annual nuclear worker dose limit, which means that if you work, for example, in a nuclear power plant, you will keep a dosimeter on you at all times. And if in a year's worth of time you get exposed to 5,000 millirems, which would be 5 rems, of radiation, you're done working for the year. And you will have to take a paid vacation for however long it is until the next year runs around where you can start up again. But you're not allowed to get exposed to more than 5,000 millirems per year. And the reason for that is because if you get exposed to that much, then you'll start to possibly see some physiological effects. Now, if you have an acute exposure, which is what this is talking about here, then if you get an acute exposure, meaning that you get exposed to it very quickly, it's not chronic, it's not that you get exposed to 4,000 over the course of a year, it's you get exposed to 4,000 in a day, well then you're dead. Because your body can't absorb and handle radiation over a long period of time. But if you get exposed to, oh sorry, I was getting my units mixed up. So if you get exposed to 4,000 in a day, you probably won't die, but it would start to cause physiological changes. So the reason they cut it off at 5,000 millirems is because at 5,000 millirems, you start to change your blood chemistry. So sorry, I was getting my units mixed up there. So this is millirems here. This is rems. So this 5 rems is the same as that 5,000 millirems. But if you get exposed to 5 to 10, you start to see changes in your blood chemistry. And then as you go up higher from there, you get to nausea, fatigue, vomiting, hair losses at 75 rem. So that is, what would that be, like 30, not 30, but 15, 20 times the limit to what you're allowed to have per year. So just continuing on this slide, talking about pretty much the same topic here about the exposure that you get from certain activities and also what you're allowed to be exposed to if you work in some kind of a field where you have exposure to radiation more than you would just naturally. If we look down here, if you take a flight across the Atlantic, because you're so high up in the atmosphere, you don't have the atmosphere shielding you as well as you do on the ground, you actually get exposed to a decent bit of radiation while you're up there in the sky. Now, you're not up there for very long, and so we don't worry about it too much, but it is about 2.5 millirems of exposure that you get from flying across the Atlantic. Over the course of a year, just from stuff in the water, you get exposed to about 4 millirems. A chest x-ray is about 10, not something you really need to worry about too much, because it's only 1/3 of what you get naturally exposed to from cosmic rays, and 1/4 of what you get exposed to just from stuff in your body. The average U.S. Background dose is about 310. Just from naturally occurring stuff. And the average U.S. Annual dose is about 620. So this is from everything that you get exposed to, including everyone in the country. The average amount is about 620, which is going to be, because it includes everyone, that's a bit, It's not, it's a bit deceiving because that takes the people that are having lots of medical things done and lumps them in with everyone else. So if you're not having lots of chest x-rays or CT scans or anything like that, then you're going to have a good bit less than this 620. It'll be closer to what we were seeing over here with just these natural sources. So probably something closer to 400 maybe or something like that. Take that into consideration here. This is the average dose for a person, and if you get just a single whole body CT scan, it is a REM, 1,000 millirems, which is a fifth of what you would be allowed to be exposed to if you worked at a nuclear power plant. So if you worked at a nuclear power plant, you have your little dosimeter, which we'll talk about later, that you wear all the time. And it measures that you were exposed to 5,000 millirems, which would be 5 REMs, over the course of a year, or within a year. Once you hit that limit, you're done for the rest of that year. You have to wait until the next year comes around before you're allowed to go back and start working again. And a single CT scan gives you a fifth of that, just to give you an idea of the amount of radiation used in CT scans. So those are not things that you want to do just willy-nilly. The reason, by the way, why the cutoff for nuclear workers is at 5,000 millirems, which is 5 REMs, is because at 5 REMs we start to see physiological effects. We start to see it have effects on the body. So these would be acute effects that we can measure, not just a chronic, because you can make an argument that being chronically exposed to radon, for example, could give you cancer, but it's more difficult to, and actually I think it's impossible to tie that back specifically to radon, but you could say that that's a chronic exposure. An acute exposure, so happening over a shorter period of time, which I know it sounds kind of funny to say that a year-long exposure is acute, but an exposure over a shorter period of time of 5 REMs starts to give you physiological changes, specifically changes in your blood chemistry. As you go up from there, you start getting nauseous. That would be at about 50 REMs. So that is 10 times the limit of what you're supposed to have in a year. 55, you get fatigued. 70, you get vomiting. You start to lose your hair at 75 REMs. And just to give you an idea of some of the absolutely terrible practices that have taken place in the past, there were open-air nuclear bomb tests that were done by the USSR back in the 60s, I want to say, where they would test nuclear bombs just out in the open in Kazakhstan, I believe. And they would test these bombs, and rain clouds would come through, pick up the radioactive elements, and rain nuclear fallout onto villages, 100 miles away or so. And people would lose their hair, over the next couple days because of that. So the average person will never get exposed to anywhere near this much, but depending on what irresponsible things are happening around you, you could possibly have that happen. So then the symptoms just get worse from there. Once you get up to 400 REM, which again is way more than the person is allowed to have here in the US if they're working in a nuclear field, you get to the point where you could possibly die within a few months, just depending on what happens. 1,000 REMs, it gets bad. You start to destroy your internal organs, internal bleeding, central nervous system shut down, loss of consciousness. Like if you get exposed to 2,000 REMs of radiation, it's not death within a few weeks. It's like you have minutes, maybe a day or two at the most. So it is really, really dangerous when you get these really high exposures. But again, thankfully, this practically never happens, at least not in modern times. I think we'll call it there for this video. In the next one, we're going to pick up talking about how we detect how much radioactivity we've been exposed to. So looking at dosimeters and Geiger counters, and then moving forward from there. So I'll see you all in the next